Hello friends, welcome back to my channel. So this video is all about matrices. So we are going to learn about matrices in this video and some important facts about matrices and some of the types of matrices. So let's get started. First, definition of matrice. A rectangular array of numbers enclosed in large square brackets. Matrix is a rectangular array of numbers that are enclosed in large square brackets. You are familiar with this square bracket? These are the square brackets. So any number that is written in these square brackets is known to be as matrix. Let us write some of the examples for the matrices. If we write like say 2, 3 and we enclose these numbers into square bracket, that is a matrix. Okay, whenever we write a matrix has a name. So if this is a matrix, it must have a name, like we write A equals to 2, 3. So that is a matrix A. Similarly, we can write some random examples like C, matrix C, 2, 5, 7, 9. So this is matrix C. So any number that is enclosed in large square brackets is known to be matrix. There are some factors that we have to be focused on related to matrices are: it always denoted by capital letters like A, B, C. That means the name of a matrix is always represented by capital letters. The name of a matrix is always capital letter. Like in this scenario, there is capital A, I have written capital C. So the name of a matrix is always a capital letter. Second number is the horizontal line. You know the horizontal line? These are the horizontal line. So the horizontal line represents rows. You all know that horizontal lines are known to be the rows, and the total number of rows in matrix are represented by small m. So when we talk about the total number of rows in a matrix, that is represented by small m. Similarly, vertical lines. Vertical lines are these lines. So vertical lines represent columns, and the total number of columns in a matrix are represented by small n. So the vertical lines are the columns, and in a matrix the number of total columns are represented by small n. So by knowing small m and small n is the total number of rows and the small n is total number of columns. So we can say the order of matrix. Order of matrix is the number of rows followed by number of columns. That is m cross n. That means the order of matrix is the number of total rows in that matrix and the number of column in that matrix. So let's move toward the first example here. A equals to 2, 3. How many rows are there? Just a single row. And how many columns are there? There are 2 columns. So the order of matrix is 1 cross 2. Similarly, in this scenario, there are 2 number of rows and 2 number of columns. So the order of matrix is 2 cross 2. Similarly, 3 cross 3, 2 cross 3, 4 cross 3. These are the different orders of matrices. So friends, moving toward the type of matrices, we have 8 type of matrices that are row matrix, column matrix, rectangular matrix, null or empty matrix, square matrix, diagonal matrix, squarer matrix, and identity matrix. So starting with the row matrix. Row matrix is a matrix that only contains a single row. Like if I write A equals to 2, 5. So friend, there is a single row in this matrix. So this matrix is known to be a row matrix. Let's take another example like B equals to 2, 7, 8. So there are 3 columns but a single row. So the matrix that only contains a single row is known to be a row matrix. So these are the examples of a row matrix. Now column matrix. Any matrix that contains a single column is known to be a column matrix. Let's get examples like P equals to 7, 6. So here a single column but two rows. A single column in this matrix, this is known to be a column matrix. Another example like Q equals to 7, 8, 9. So there are three rows but a single column in this matrix. So this matrix is known to be a column matrix. The matrix that only contains a single column is known to be a column matrix. Now friends, moving toward the next one, that is the rectangular matrix. For rectangular matrix, there is a condition. As we have learned that the total number of rows are known to be are denoted by small m, and the total number of columns are represented by small n. So there is a condition for rectangular matrix, that is m is not equals to n, which means that the total number of rows are not equals to the total number of columns. That any matrix where the number of rows and the number of columns are not same, that is supposed to be a rectangular matrix. Let's take an example. Here is 2, 6, 7 and 5, 4, 0. So that is a case of rectangular matrix. As you can see, there are 3 columns but 2 rows. Let's take another example like we have C, and let's suppose we write 7, 9, 0, 2, 5, 6. So in this case, there are 3 rows but 2 columns. The number of rows and the number of columns are not similar. So this means that this matrix is a rectangular matrix. Moving toward the next matrix, 7, 9, 0, 2, 5, 6. So in this case, there are 3 rows but 2 columns. The number of rows and the number of columns are not similar. So this means that this matrix is a rectangular matrix. Moving toward the next matrix is null or empty matrix. Any matrix which contains only 0. Whatever the order of a matrix, it's 2 cross 2, 3 cross 3, 2 cross 3, 4 cross 5, whatever is the order of a matrix, but that matrix only contains 0 as its element, is known to be a null or empty matrix. For example, we can say P equals to 0, 0, 0, 0. So that is a null matrix. Or we say B equals to 0, 0. That is also a null matrix. So any matrix that contains only 0 as its element is known to be a null matrix. So friends, let's move toward the next type of a matrix, that is a square matrix. There is a condition for the square matrix, that is m is equals to n, which means the total number of rows in that matrix must be equals to total number of columns. That is, the order of matrix must be 2 cross 2, 3 cross 3, 4 cross 4 and so on. Let's take an example like I write Q equals to 6, 7, 9, 0. So here are 2 rows and 2 columns. So this matrix is a square matrix. Let's take an example of 3 cross 3. Like we write P 3, 0, 9, 2, 4, 7, and I'm just taking random numbers 1, 2, 3. So here friends, there are 3 rows and 3 columns. That means this matrix is a square matrix. So any matrix that contains same number of rows and same number of columns is in the category of square matrix. Moving toward the next type, that is the diagonal matrix. For diagonal matrix, first condition is a diagonal matrix must be a square matrix. That means the number of rows and the number of columns in the diagonal matrix should be same. Second thing is that in diagonal matrix, there are numbers on the diagonal and all the elements other than the diagonals are 0. Let's take an example. K equals to, I write 1, 0, 0, 2. So as you can see, this is the diagonal and the only non-zero numbers are in the diagonal and the other numbers are 0. Let's take another example. Suppose we have write L, matrix L, and we have write 1, 0, 0, 0, 1, 0, or I have write 0, 0, 2. So as you can see in the diagonal there are the non-zero numbers and other numbers are just zeros. So this type of matrix is known as the diagonal matrix. That means in the diagonal there are non-zero numbers and other than the diagonal there must be all numbers 0. Okay friends, there is one important point to be focused on. After the square matrix, there is diagonal matrix, scalar matrix and identity matrix. These three matrices must be square matrix. First the condition holds for the square matrix, then some different conditions are applied on them. Moving toward the scalar matrix is also a square matrix and a diagonal matrix, but in scalar matrix, the numbers in the diagonal must be same. Like we say, take an example, like we say A equals to, I write 2, 0, 0, 2. So in this case, the diagonal contain the same number of the diagonal contain the same number as its element. Let's take another example. Suppose we take W and I write 1, 0, let's take another name. 4, 0, 0, 0, 4, 0 and 0, 0, 4. So here in case the diagonal contain the same number, that is 4. Other than the diagonal there are zeros. So this type of category is known as the scalar matrix. For scalar matrix, the matrix must be a square matrix. That is, the order of matrix should be same, number of rows and number of columns. Then a matrix should be a diagonal matrix. That means there will be non-zero elements on the diagonal and the rest of the elements are 0. And third condition is the number on the diagonal should be same. Okay, friends, let's move toward the last category or last type of the matrices, that is identity or unit matrix. For the identity or unit matrix, the first conditions hold. It should be a square matrix, then it should be a diagonal matrix. But for an identity or unit matrix, a matrix, it is always represented by capital I. Whatever it be the order, the matrix contain only 1 as its diagonal and the rest of the numbers are 0. For example, I write an example of 2 cross 2, 1, 0, 0, 1. So here 1 is on the diagonal and the other numbers are 0. Let's take an example of 3 cross 3. 1, 0, 0, 0, 1, 0, 0, 0, 1. So this is a 3 cross 3 matrix and in its diagonal there is 1. So friends, we go through the matrices. Let's sum up or summarize the topic. Matrices are any number that are enclosed in large square brackets. Okay. Then we have gone through the types of matrices. I hope this video must be informative and knowledgeable for you. So if you like my video, if you like my content, please do like, share and subscribe to my channel. And for the next video, we will meet in the next video. Till then, take good care of yourselves and stay blessed.